looking at the question 7 and the parts before, you understand that the lion starts off faster than the zebra and is overtaking the zebra, and that there's 40 metres between them. So, because the lion is slowing down over time, if the lion doesn't catch the zebra, if the lion doesn't catch up 40 metres before the zebra gets faster, then they will draw apart. So to answer part G, you need to first of all find the time where they're travelling at the equal speed, and so I would draw a graph on your calculator and find the point of intersection to solve for the time. So to get a good comparison graph, from doing the sketches earlier, you would have seen that the intersection's around 5 to 6 seconds. You know that the maximum speed is going to be 20 metres per second. So I've got the x value 0 to 10, that will include the intersection point. The y value, I'll start at 0, and we know that the maximum is 20. I'll put dot 0. Don't want that. Maximum 20. So now I'm going to enter the two functions, velocity 1, 15, e to the minus 0.1, and function 2 was 20, take 20, and just going to shift G solve intersect, and we see it's 5.6 seconds when they intersect. So now we want to calculate the distance between the lion and the zebra. So if we do the integral of the lion who is travelling first, and we take away the speed of the zebra, over the time interval to where their speeds are equal, that will give us the gap between the two. So you did a graph earlier and you saw that the zebra started at 0 speed and approached the maximum of 20. And the lion started with speed at 15 approximately, and its speed decreases, approaches 0. So we've worked out that this point of intersection is 5.6 seconds. And what we're doing is we're looking at this area, velocity 1 compared to 0 axis, take away velocity 2. So the integral with velocity 1 gives you the area under the velocity 1 curve in respect to x equals 0. And the area under velocity 2, the zebra, is this little bit here. So the zebra is travelling slower initially. And when you take the upper function from the lower function, you get the difference. Now, so that's what this formula is doing. So let's put in the values. So the velocity 1 function was 15e to the minus 1.1t. And we're taking away the lower function, the v2 function. So we're taking 20 take 20e. So it's going to be plus 20e to the minus 0.1 t with respect to t. And let's do that on the calculator. So I've changed the run menu, choose the option button, calculate, definite integral. Definite integral doesn't show, so my emulator has not defaulted to the math mode. So go shift, setup, choose the math mode, try again. So option, calculate, F4, now I've got the definite integral. So my top function is 15 e to the minus 0.1 x, and I'm going to take 20, take minus 20 is plus 20e to the minus 0.1 x. And I'll put brackets in just to make sure. And from 0 time to 5.6. Now that difference is 38.08 metres. And they started off at 40 metres apart, so the gap between the lion and the zebra is 40 take the 38. So the lion does not catch the zebra, misses by 1. Okay, so the zebra starts drawing away after the velocities are equal, but only 2 metres apart. It was pretty close.